My name is Greta Tjeltveit. I work with Fourier Building Science. This is Balanced Ventilation 101, Concepts, Benefits, and Configurations for Multifamily Buildings. So I like to joke that there's Greta Thunberg, and then I'm the other Greta T, Greta Tjeltveit. It does start with a T despite how it sounds. Sarah did a great introduction. If you want to hear more of a deep dive of my background, I strongly encourage you to check out the Passive House Accelerator podcast interview that I did, and would particularly recommend this to anyone who is, just getting into the industry or wanting to find more opportunities in the industry. My pathway rather, has been a bit of a winding road and search for things that I didn't even know were professions. So I'm thankful that I had people in my life that were willing to stick their neck out for me when I had no idea what a perfect wall was. And that they were willing to sit down with me and talk about what they did so I could help, find my passion. That being said, I'm also happy to sit down with others to do the same, so don't hesitate to contact me. I'm hoping to pay it forward to all those who helped me get to where I am today. With that, I work for Fourier Building Science as a building science consultant. We're a building enclosure consultancy based on the West Coast, primarily servicing projects in the Pacific Northwest, but we have plenty of projects around North America and offices in Seattle, Oakland, California, and Vancouver, BC. We work on both new construction and existing buildings, commercial, residential. We do forensics and leak investigations, as well as design, site testing, energy modeling, and passive house consulting and verification. So why am I here today? We're going to quickly go through Balanced Ventilation 101 concepts, general benefits. The primer that Zach shared with us is great, just kind of, dipping our toes into this. And then I'll also quickly plug Passive House Accelerator has a ton of great resources for, previous presentations on balanced ventilation. A specific shout out to Andrew Peel's 101 ventilation presentation he gave earlier last year. So I'm not going to spend a ton of time on those first two bullet points there. The bulk of the presentation will be sort of case studies in configurations of balanced ventilation systems for multifamily buildings, specifically looking at unitized or individual unit by unit systems, centralized systems that have sort of a horizontal floor by floor approach, and then centralized systems that utilize building wings with vertical stacks to address ventilation needs. So why does ventilation matter? Why are we even talking about it? In conventional buildings, fresh air leaks in through cracks. For passive projects that are airtight, we need some sort of mechanical ventilation to keep air quality high, protect durability, get fresh air, and maintain comfort, while also meeting strict energy targets. What is balanced ventilation? So I was always told balanced ventilation is sort of the lungs of the building, hence the graphic. Balanced ventilation means supply and exhaust airflows are equal, so the building stays pressure neutral. Supply zones, or rooms that you'd see supply air going into, are typically living room, bedrooms, office, and the like. Extract or return air rooms would be your kitchen, bathrooms, and laundry, to rid of moisture, humidity, pollutants, and stale air. Balanced ventilation systems capture heat and sometimes moisture, which I'll get into in my next slide, from the outgoing or exhaust air, and transfers that heat to the incoming fresh air. So the system is able to maintain or recover some of the heat from the indoor environment and use it to sort of temper the incoming fresh air. So it's an active system in that there are blower fans working to simultaneously exhaust stale air from the indoor environment and pull fresh air across filters and the heat recovery core. So it's a passive heat recovery, and that we're not using any energy to generate heat or make heat. We're just transferring it. So the HRV or ERV concept, you have your heat recovery ventilator and your energy recovery ventilator. So these are controlling airflow into and out of the building. Specifically for an HRV, it works by stale air leaving the building that passes through. So let me use my mouse. Exhaust air from the home passing through the heat transfer core, and then fresh air from the outside, essentially using or being tempered so that the fresh air coming in gets a little bit of a heat boost, if you will. In ERVs, moisture is also transferred to help better maintain humidity levels in the building. So the result is fresh, filtered, preconditioned air at a fraction of the energy cost. In terms of energy benefits, because we're recovering heat that would otherwise be lost when exhausted to the outdoors, the heating systems in the building don't have to work as hard. So this reduction in demand means that your building systems, whether it's heat pumps, radiant heat, et cetera, can be sized to be smaller and more cost effective to operate. So example that I have here is, imagine we're in a heating dominant climate somewhere, like Minnesota, where I'm from, in the winter. Imagine the indoor air temperature is about 20 degrees Celsius and the outdoor temperature is about 0 degrees. As warm indoor air is extracted and passes through the heat exchanger, its heat is transferred to the incoming cold air. It's not mixed. It's essentially just transferred over, again, to sort of pre-temper it. This process warms that fresh air supply to about 18 degrees, assuming that this recovery unit is operating at about 90% efficiency. So compared to simply opening a window and letting in unfiltered 0-degree air, the difference is pretty dramatic. Another benefit is comfort and indoor air quality. Balanced ventilation also improves occupant comfort. Fresh air is continuously supplied, pollutants are filtered, and humidity is kept within a comfortable range. It's both an energy efficiency and health strategy. So the photo that I have shown here is of furnace filters, not ERV or HRV filters. I couldn't find the photo I took of a Passive House Project's filter, but between commissioning, when the HRVs were first turned on, like still in construction, and then shortly before the tenants moved in, during wildfire smoke season here in Seattle, the filters looked about like this. Like just for that short time period, because of all of the nasty smoke and some of, construction dust and other things going on, the contrast between a new filter and the one that was used for a short period of time was pretty stark. While not Passive House specific, I also just want to mention the photo comes from Building America Solution Center. They're a great resource for building sustainable and durable buildings, a lot of which align with ResNet, HERS, and Energy Star requirements. Plus their photos for like good versus bad installs are fantastic. The training segment for replacing furnace filters thoughtfully shows how to replace them, and also literally shows a photo of someone throwing their filter into the garbage when it's done. So very, very thorough indeed. Many balanced ventilation systems also include a boost function to be used when there are particularly high humidity events, like when you're taking a shower or you're having a party of folks over. So it can be increased to sort of manage the moisture and humidity levels that you're dealing with. Obviously, as Zach had already showed us in the primer, balanced ventilation isn't an option in passive house. It's a requirement. Without it, you can't achieve the comfort, energy, and indoor air quality standards that define the passive house approach. And it's has various prescriptive requirements as it relates to certification for PHI and PS. Okay, so we got through the 101 level. Now on to kind of the bulk of the presentation. We understand what a balanced ventilation system is, how it generally works, the benefits it has, and we need to ensure that balanced ventilation systems or balanced ventilation rather, is being provided effectively and efficiently to spaces and residents for optimal comfort and air quality, while also considering things like maintenance, the square footage that these systems take up, especially as it relates to units and amenity spaces, and then some of the implications for testing and balancing. So it's definitely more of a qualitative discussion and case study, but hoping that you're able to take something away from it. So first of all, why does configuration matter? Just at a high level, it impacts maintenance, which then has an implication to tenant disruption. If you do have any of the units or systems that need to be maintained in any multifamily residential units, and then just general cost. How many filters do you have to replace based on how many systems there are? It is by no means a one-size-fit-all approach. It's so dependent on site constraints, the type of occupancy you're dealing with. So this is just kind of a look into that. So there are two projects that I'll highlight. There is Hobson Place South, and then LE Passive House, both of which are FIAS certified, which I was the FIAS verifier for. For LE Passive House, I have the project team listed here. It was a C-shaped building with covered walkways and open air courtyard, 7 stories, 66 units total, 63 of which were apartments, both mix of studio and 1 bedrooms, and then 3 live-work units on the first floor that were double height, like lofted spaces. It's a combination of interior and exterior access units, and it's 5 wood frame stories over 2 type 1A construction, and utilized a hybrid of centralized sort of floor by floor or horizontal zoning of HRVs, in addition to unitized systems or individual units for those 3 live-works on the first floor. And I'll show a graphic for kind of how things are split in a moment here. So there were a total of 15 HRVs used for this project, 12 for servicing multiple units or groups of units, and then 3 smaller ones that were used for those live works. So here's how these zones were sort of broken up. For levels 1 and 2, you have the green, purple, and red that show the individual units for those live workspaces. And then from that point on, it's basically floor by floor, usually serviced by 1 to 2 HRVs. So as you get further up in the building, basically an east and a west zone. So again, the live work units each had their own individual HRV in the bathroom ceiling of the lofted portion of the space. Consideration for that is one of the supply diffusers, you can kind of see over here on the left, was kind of difficult to reach in that it was at like the top of this ceiling lofted space that made it kind of difficult to get up and verify the airflow for. The pros of this is there's autonomy in having just 1 system per unit. It's very simple to balance in that it's all, fewer grills and intakes and exhausts. So by changing one airflow, it's not going to too drastically affect the other. I've just personally found it to be a bit easier to balance smaller units. A con here is it's, more units to maintain. You are needing to go into these individual units. That's across these 3 units, that's 6 filters that you're having to change out every so often. Units do get to control their own systems, which is great for comfort, but it does mean more equipment to install and more penetrations through the enclosure. Each of these systems needs to have a duct for intake and a duct for exhaust. So similar to the filters concept, that's also 6 penetrations to detail just for these 3 units. The remainder of the floors, again, this sort of centralized horizontal floor by floor approach. So the ducts and the trunk lines were primarily within soffitted space, either in the hallway or across like bathroom areas. They don't penetrate between floors. And each HRV is situated in a mechanical closet, sort of tucked at the side of the building that's right up against a neighboring existing building. Benefit here is centralized service, one unit feeding multiple, one system feeding multiple units, relatively less disruptive for maintenance, but still, a couple units per floor to, maintain. Somewhat of a con here is, longer duct runs as opposed to, potentially individualized systems, and, need for more soffit space in your hallways. A quick note about mechanical spaces. I include this for all of my HVAC mechanical folks. When using a horizontal or floor by floor balanced ventilation system, having enough space to install ductwork without jamming everything into a small closet is really, really critical. So for especially those on the design side of things, designing for space for those important systems, especially balanced ventilation, and getting buy-in and input from your mechanical teams early on is really important. In terms of balancing and commissioning, again, in my experience, smaller systems are a bit simpler to accurately balance or do sample verification of, but that's just going to be kind of project to project dependent. As for just kind of high level pros and cons for these hybrid centralized horizontal and floor by floor plus unitized systems, a huge pro here, this project is located in essentially downtown Seattle, near Seattle Center, so by the Space Needle. And a big selling point for the market rate units was a lot of rooftop amenity space that looks right at the Space Needle. So having no area required on the roof for these mechanical systems was a huge plus. And no vertical shafts running through each unit was really important in terms of like fire smoke dampers, and keeping all of the equipment within the building enclosure. A lot of considerations when thinking about the thermal impacts of ductwork being outside of our passive house envelope. Cons is, you do need space on each floor. As I mentioned, a consideration for the design team to have enough room to run the ductwork, and then needing additional floor height to accommodate corridor soffit space for those horizontal trunk ducts. Okay, our next case study is of Hobson Place South. Project team is listed on the upper right-hand corner. This was a permanent supportive housing project for residents who've transitioned out of unstable living situations. It's an H-shaped building with double-loaded corridor, 7 stories, 92 studio apartments within 4 stories of wood-framed construction over 3 stories of type 1 concrete construction levels. So this project utilized 3 Swagon rooftop units servicing 4 floors of residential with a minimum calculated heat recovery efficiency of 80%. I would say it's more common to see like balanced ventilation systems on or to have rooftop units as your balanced ventilation systems as a way to, maximize your interior square footage. But just being careful on how those are designed and optimized to not have an entire roof filled with equipment is beneficial. So this is the general layout of the different zones. So again, the centralized building wings or multi-unit vertical stacks. A huge pro here is, economies of scale. So these 3 ERVs were able to service all 92 units, and sought out a code alternate to actually be able to bring most of the ductwork under the roof's air barrier to minimize roof penetrations for all of the ductwork that was needed, which I'll show a little bit later in the presentation here. And then this is kind of an up-close view of the stack from the southwest side of the building. The sort of orange peach color showing where the Swagon ERV on the roof is located. To avoid smoke dampers for this project, they used 4-inch ducts of a certain gauge that could penetrate multiple floors without requiring the fire smoke dampers. The ducts run from the main trunk on the top floor through vertical shafts in the bathrooms and closets to each unit. And in the next photo, or slide rather, this kind of gives you an idea of these main trunks that are situated at the very top floor in the hallway soffits. So as I mentioned, this project did seek an IBC code alternate that was approved by the city of Seattle to bring the main trunk into the building enclosure within a dropped 1-hour rated ceiling. So general fire rating considerations, you can see on the right-hand photo, there was car decking that they then covered with 1-hour rated gyp on the left. This is a design consideration, kind of similar to the previous project of just having a taller ceiling height on the top floor, needing that additional space to be able to run ductwork, in your hallways. For this one, there was a lot of other stuff that was already being run through many of the hallway soffits. So the fact that they could keep all of the ductwork or majority of the main trunk lines in the top floor and then run the rest of the ductwork sort of into the units through bathrooms and closet shafts was really beneficial. Just kind of another note for balancing and commissioning, especially with these, larger systems that can definitely push quite a bit of air. Being sure that you're coordinating these relatively low airflow rates required for passive house, especially for like studio apartments, with the testing and balancing contractor. Because sometimes the equipment that commercial tab contractors have doesn't read as low as some of the airflows that are being required for these types of units. So making sure that you're, working with your tab contractor early to understand that as they start to balance these larger systems. So pros and cons of the centralized building wings. Huge pro is it does also keep most of the ductwork within the building enclosure. Far less maintenance in terms of having fewer units and less invasive to residents, right? So especially for this project where this is permanent supportive housing, people transitioning out of oftentimes being on the streets, limiting how much time maintenance folks need to go into these spaces is really, really beneficial and was important to the project team. In terms of cons, again, needing that additional height on the top floor to accommodate the ductwork. And then it did require the code exception slash alternate, which would be at the jurisdiction and fire marshal's discretion. Okay, I absolutely love showing this slide. On the left, you have the rooftop of Ellie Passive House, the one that's near Seattle Center, showing the amount of rooftop amenity space that there is, as well as a huge array of solar panels. So by bringing all of those HRVs inside, they have the ability to maximize a lot of other use for the rooftop. And on the right here, Hobson Place was a two-phase project. So the south side was the one that I was, highlighting. The north side was not pursuing passive house certification. And you can see just how much ductwork there is on the roof, how many different, how much more it appears, systems had to go on the roof, and that there, wasn't necessarily room for solar or, other spaces up there. So that's a huge consideration when configuring your balanced ventilation systems as well. Getting into conclusions here, as I mentioned, it's going to be project by project based design and configurations, but just wanting to highlight some of the pros and cons of the various different configurations that I've seen in passive house projects. But obviously, design what makes sense for the building type, site constraints, project goals, and occupancy or end user. And then integration of key testing and commissioning players. Your raters and verifiers out there, myself included, would appreciate that, as well as your testing and balancing contractors. Just coordinating early and often to get everyone in on the design and layout makes a huge difference. A quick acknowledgement for the exemplary building program by the Housing Development Consortium of Seattle-King County. They put together this awesome guidelines for balanced ventilation with heat recovery, which is a part of a series highlighting techniques for designing and building better affordable housing. But it can be followed by anyone. It's not just affordable housing. It's a great resource just for optimizing various systems for better buildings. We've got time for questions, and I'll throw my thank you slide on after.
You can go ahead to your thank you slide, because I think before we hit the questions, we have a couple of things that we need to do, but I just wanted to say that was a fantastic presentation. It was so interesting to see, and I really appreciated the breakdown that you did of the different types of configurations that you can do. I think before we go to questions, Sarah's got some things that she's got on her list. So Sarah.
I sure do. We do have some awesome questions. I am going to starve you all of the answers for one quick second because I would like to show you all around some of the events we have coming up. So let me remember how to share my screen on Zoom. Sweet. Okay. Let me know if I'm pulling a Zach and you guys can't see my screen. But I wanted to.
Yet.
Oh, can't see it yet. All right.
I do like the pulling a Zach, though. I might have to use that.
And he's not here anymore, so that makes it even better that you're saying that.
Okay, screen 2, share. Come on, Zoom. There we go. Okie dokie, artichoke. So we have a few things on the docket. One is if you're like me, you just can't get enough of Greta. And so she has a podcast coming up here. If you want to talk a little bit more about her work in the PNW, the Pacific Northwest specifically, Greta's going to be able to tell the future with that. So that's great. We also have a component spotlight tomorrow, October 2nd. This one is online and it is a spotlight with LG. It's choose your own adventure, kind of choose your own hydronic adventure. That's really quite fun. Totally urge you guys to check that one out. And we have some community events. My favorite. I love community events. I am so curious about who is planning to go to the FIASCon next week. That's going to be in Milwaukee, not the Milwaukee outside of Portland, which always confuses me. It's the Milwaukee in Wisconsin. Also next week is the Building Science Symposium. That's in person in Philly. Awesome. If you go, please get a Philly cheesesteak for me because I didn't get enough of that last time I was in Philly. And then we have following the International Passive House Open Days. That's global. Cool. You can catch it from wherever you are. And then last but not least on here, we have the Reimagine Buildings, and it's going to be a best of retrofits. So that's also online and that's in December. Totally hope to see you there because I will for sure be there. And last but not least, if you are a little curious still and you want to pick the amazing genius brain of Greta a little bit more on a balanced ventilation, join us on Friday. This one's coming up quick. This is on Friday, October 3rd at noon. I believe that's noon Eastern. Kim, you can totally, yep, she's nodding. It's noon Eastern. Ask Greta anything about balanced ventilation. Alrighty, folks, I'm going to hand it over to Kim to thank our sponsors. Thanks, Kim.
Awesome. Thank you, Sarah. And thank you, Greta and Shefali. Quickly, just want to thank our sponsors for helping us to make these events possible. Our founding sponsors, 475 High Performance Building Supply, Ingui Architecture, Partel, Rockwool North America, and Sola. And over to our champion sponsors, Bowiso, Cascadia Windows and Doors, European Architectural Supply, Facro, Intelligent Membranes, Icon, LG, and Source 2050. Our patron sponsors, Building Type, Brennan, Holzraum System, Innotech, Lamelux, RDH Building Science, and Sanderson Design. And finally, our stakeholder partner is NYSERDA, the New York State Energy Research Development Authority. And a reminder that the link to join the LG Component Spotlight is in the chat. So hope to see you all tomorrow. I'm going to hand it back over to Shefali and we will get our Q&A started.
Thanks, Kim, and thanks again to all of our sponsors, without which all of this amazing free programming would not happen. So I have the honor of asking you the first question, Greta, so I'm going to turn it over to myself. For unitized systems, so I guess I'll preface it by saying we do a lot of affordable passive house projects, and we have a couple of issues that we grapple with when we talk about unitized ventilation as opposed to the more centralized system you talked about at the end. Do you provide training for tenants for them to understand like what this is, what kind of benefits it provides, and how to operate the system? And are there questions about who pays for the operation of it? Because it's in the unit, and so in my mind it would be tied to their panel, but and for affordable housing, we try to limit, right, what the tenant has to pay for, especially if in New York City, often it's lottery based and you may not have that choice of where you live. So we never want to put them in a position where they're paying more on their utility side because they ended up in a passive house building.
Yeah. So to answer the first part of your question, I, especially with my background at Habitat for Humanity, am a huge advocate for educating residents and homeowners about these systems. I have talked to so many people. You can build the most, sustainable, energy efficient home in the entire world, but if the people owning it or operating it, living in it day to day, don't know how to work it, what impact has that really had? We personally don't provide any training. I know sometimes that does fall on for these larger projects, like the contractor to provide documentation or some sort of training to the leasing office or maintenance staff, who then may provide some sort of pamphlet to the residents. But it does sort of trickle down from ultimately the folks that are originally installing it. So that does get lost. I would love nothing more than to collaborate with folks on some sort of like passive house tenant education system, whether that's I don't want to say like a binder, but something along those lines, for folks to become more familiar with these systems, since we're, especially in like the Northeast, there's so many passive house projects going in. And I mean, I'll be honest, I didn't know how to operate a tilt and turn window until within the past decade of my life. And now they're being put in so many projects, and wanting to like maintain that hardware in those systems is very important. The second part of your question, in terms of like who's paying the cost for those systems for unit by unit approach, my hope is that it wouldn't be too much, right? Like if we have a relatively high efficiency system and it's energy used just for the blower fans, that wouldn't be a ton. To be honest, I don't know enough about what utilities look like in affordable housing, and again, familiarity with use, and if people are wanting fresh air, so they open a window, but their heating system is still on, and then they're losing heat and having to pay for that. To me, again, it does still stem from education. But I would love to hear, other people's thoughts on how to sort of work out the utility side. There's so many, different options there, but would be happy to chat more with you about that in the near future.
That's a really thoughtful question. I just jotted that down too with some of the work that I do. Thanks for asking that, Shefami. Okie dokie. Chris, no last name, Mysterious Chris. Are you on the call? Would you like to ask your question? You can try to answer it too, but we have Greta here if you want to ask it.
Oh yeah, can you hear me?
Yes, we can. Hi, Chris.
Yeah, I just, in both of the floor plans I saw, I did not see kitchen ventilation, so I was curious how the kitchens are getting ventilated in the buildings.
Yeah, great question. So I believe both had recirc hoods. Actually, that's a lie. The first one had recirc hoods, and I believe Hobson Place South, don't quote me on this because it's been a few years, had direct vent to the outside. I think that decision was in part because of the occupancy type. I'd have to go back and double check, so I'd be happy to follow up with you.
Yeah, I'd love to know about makeup air if you are venting to the outside with a hood. And if recirc is allowed with no other kitchen ventilation, is that a Seattle-based code then? Because I'm in New York, we have to ventilate the kitchens.
Yeah, I think that a few of these projects have gotten code exceptions or alternates for studio spaces, where the bathroom exhaust is, the bathroom's like right across the way from the little kitchenette area. So sometimes they're able to say that just some of that exhaust is going into like the bathroom, is kind of my understanding. But it has varied across projects, and I do know, sort of to Sarah's comment in the chat, kitchen exhaust strategies is definitely a hot topic. And I know there's been changes with codes across the US, as well as some discussion with like FIAS about how to approach those. Yeah,
Yeah, this is a
can't
tough
remember
nut
off
to
the
crack.
top of my head.
Okay, thanks.
Yeah, Chris, we also do, as I mentioned, Passive House in New York City. So if you have New York City specific questions, feel free to reach out. So next up is Andrew, who asked that we ask his question for him. So I will go ahead and speak for him. Is it considered best practice to aeroseal the interior ducts, supply and return, or test them to a certain leakage spec, or is there no standard?
Great question. So I know that it has become more commonplace here in Seattle to use AeroSeal for sealing ductwork, for balanced ventilation systems. Again, in an effort to try to maximize the efficiency of these systems. I believe Hobson Place did use AeroSeal. Don't quote me on that, but I'm pretty sure they did. And they did sample testing for duct leakage. For FIAS projects, it oftentimes is required. There's some consideration for the length of ductwork that triggers when you need to test versus not. The general layout of the ducts to essentially say, if they were all sealed this way, and we can just test a sample to show that it's meeting the requirements for duct leakage, then that's sort of good enough. But I know that it's been it's sort of varied across projects that I've been on.
Great, thank you for that. Next question, I'm gonna go ahead and ask for her because I think she jumped off the call. This is from Catherine Duff. Are these ducts insulated?
Yes, great question. So typically, you're insulating your ductwork for your incoming fresh air, usually because there's a pretty big temperature delta or difference between outside air and inside air. And then similarly, you're insulating your exhaust duct because it has been, either stripped of its heat or vice versa with cooling, and can have that same delta T as it gets exhausted to the outside of the building. There are requirements around like minimum duct insulation, and then encapsulating that in some sort of airtight vapor barrier. So making sure, kind of to my point about if you're going to stuff HRVs in a mechanical closet, giving it enough space not only for the ductwork, but then for the insulation around the ductwork. That's something that often gets missed. It's not just the ductwork itself. There's insulation to it.
Great. Andrew has a community question, so I'm just going to point everyone to the chat because I think we agree that it's an interesting question, but I think it's open to everyone here. So I'm going to skip this one and go to Christopher. Christopher Lee, are you on the call? I can't see you.
How you doing?
There you are. Okay, go ahead.
Hey, I was just curious if you had any thoughts on placing ERV supply and exhaust registers relative to heating and cooling registers, just with regard to the kind of pressure effects that could end up happening due to the disparity in CFMs.
Yeah, that is a great question. So for these two projects, because of the amount of internal heat gains of like very dense living, most of the units actually had just a small amount of electric resistance for heating load. A few of the units on the LE Passive House, especially on the west elevation, did have mini splits, but they were just ductless. ductless heads on the wall to kind of help with additional comfort for cooling capacity. And then a few of the south-facing units on that same project had, I believe it was Chiltrix, to add in some cooling to sort of temper the balanced ventilation, fresh air going into the units. So in terms of putting them like near grills and the heating and cooling systems, we don't have a lot of ducted systems out here. You're seeing more of it start to come through, but we're a pretty moderate climate relative to maybe other parts of North America. So we haven't necessarily had to consider that and placement of those diffusers, because we've been able to get away with electric resistance, cove heaters kind of stuff, or ductless mini splits. So I think it's more so been a consideration for where best to place the diffusers to not only minimize duct runs and their geometry, like limiting the amount of bends, but then putting them into very much like centralized spaces to supply or exhaust different areas. And again, ease of maintenance, and then being able to test and balance those. In these small studio units, there's really only so many places to put them. So while it doesn't necessarily get at your question of placement for diffusers, that's more so the considerations that we're dealing with out here, since we don't have a ton of ducted systems.
Gotcha. Thank you, Greta.
Yeah.
Yeah, great point. I'll just add, from being out in the field doing a lot of commissioning work in single family housing, probably don't put it like inside the shower area. Maybe just offset that a little bit. Hot tip. Next up is me. I have a question for you, Greta. How does the maintenance work in these cases? Do you guys have a contract with the HVAC folks to come in X amount of times for filter changes? In unit by unit cases, are the homeowners aware that someone's going to come in X amount of times?
Great question. We don't do the maintenance work ourselves, but I feel like in recent years, especially, I feel like Dan Whitmore has brought this up a lot, in part because he developed his own passive house project and is helping to maintain it and whatnot. So he's become aware of like, what is our maintenance budget to replace these filters, and is that enough to, you're not only maintaining the balanced ventilation systems, you're maintaining landscaping and so many other things. And just considering the time in which it takes to maintain a building, so having those centralized locations to make it easier. We don't do it, but again, I am just trying to encourage people to remember that that's something to consider for the longevity of the building. Because again, you can make these buildings as efficient as possible, but how can we make sure that they're being maintained and remain durable and resilient for years to come, decades to come?
So there's some good chatter in the chat, and I would recommend that everyone check it out and chime in. But I do want to remind everyone that this Friday, Greta, it will be in the Reimagine Buildings Collective to do an AMA with Sarah. So I think, if you had a question, or if you want a real deep dive, I would strongly recommend that you join the AMA. It's at noon. Yes, Kim? And definitely check out Greta's podcast episode. I think that some of these, and Greta, maybe you can read the chat to be prepared for maybe slightly more technical questions that are probably going to come your way when you do this on Friday. I just wanted to say that because I wanted to respect everyone's time, in case you have to leave right at 1. But it does look like we have time for one more question, and it's from Andrew, and so I'm just going to ask it. Are each of these units sub-metered for electricity? And does that sub-meter include the ERV, lighting, and heating and cooling and domestic hot water? Or is the ERV costed to the building like central areas, hallways, if there is metering? Do you know?
So for the second project, it's all centralized. Again, just mostly based on like occupancy type for permanent supportive housing. For the first project, I'm not sure how the horizontal floor by floor systems that are servicing multiple units have their utilities split up. I'm happy to look that up between today and the AMA session. I feel like I've got some homework to do ahead of that. But I do know that those live work units with the unitized systems, do have that on their individual meter. So, yeah.
Great. Thank you. And that brings us to the hour. So thank you everyone for joining us today. Thank you, Greta, for this very informative and fantastic presentation and for spurring this fantastic conversation. And of course, thank you, Sarah, Kim, Zach, and we have this pull a Zach joke, but I think most people are going to say if you're pulling a Zach, you're doing something really amazing, and we're going to have to be like, no, we're joking. So anyway, I hope everyone enjoys the rest of their Wednesday. Thanks, everyone. Sarah, any last words?
Thanks, guys, for such a great discussion. Yeah, it's great to be back and see you all.